name is Sergio Mesiga and my partner is Johnny Sebastián Cifuentes.
Hello.
We are students of Mechatronics Engineering and this course is Technical English.
Okay, our topic is the sensors. Okay, in the broadest definition, a sensor is a device, module, machine, or subsystem whose purpose is to detect events, change in this environment and send the information to other electronics, frequently a computer processor. A sensor is always used with other electronics. Okay, technical characteristics of a sensor. Measuring range. Domain in the measured magnitude in which the sensor can be applied. A price is the maximum expected measurement error. Offset or zero deviation. Value of the output variable when the input variable is null. If the measurement range does not reach null values of the input variable, another reference point is usually set to define the offset.
We can find other technical characteristics, for example, linearity or linear correlation, sensitivity of a sensor, assuming it is input to output and the variation of the input magnitude. Resolution. The resolution is minimum variation of the magnitude of input that can be detected at the output. Quick response. It can be at fixed time or dependent on how much the magnitude to be measured varies. It depends on the ability of the systems to track variation in the input magnitude. Drifts are other magnitudes apart from the measured as input magnitude that influence the output variable. For example, they can be environmental conditions such as humidity, temperature, or others such as aging, oxidation, wear, etc. Other technical characteristics is repeatability, expected error when repeating the same measure several times. Okay, a sensor is a type of transducer that transfers the magnitude that you want to measure or control into another which facilitates its measurement. In general, the output signal of the sensor is not suitable for direct reading and sometimes not for processing, so a condition circuit is used. For example, a Wheatstone bridge, amplifiers, and electronic filters that adapt the signal at the appropriate levels for the rest of the circuits.
Okay, we can find the different types of sensors. Linear and angular position. We have a potentiometer, his output is analogic. A Hall sensor, his output is digital, and encoder, his output is digital. We can find sensors of displacement and deformation, strain gauge, and linear variable differential transformer. His output is analogic. We have linear and angular speed. We have a dynamo. His output is analogic. And encoder, his output is digital and gyroscope. We can find sensors of acceleration. We have an accelerometer. His output is analogic, and servo accelerometers. We can find sensors of temperature. We have a thermocouple. His output is analogic. Resistance temperature detectors. His output is analogic. thermistor, for example, PTC resistance increases as temperature rise, and NTC resistance decreases at temperature rise. We can find sensors thermostat.
In this part, we can find a photodiode, a photoresist, phototransistor, and photoelectric cells. In this part, we can type of sensors is proximity sensor or presence sensors. We can find capacitive, limit switch, sensors of inductive, a sensor of optics, and sensor photoelectric. Pressure. Find membranes, piezoelectric sensor, and digital manometers.
Okay, we hope you liked this video. Thank you.
Thank you.
Bye bye.